Okay, so since this is the extremely hard problem, you should not have to worry about a problem this tedious on the AP exam. So I will just go through it quickly. You can pause it at any point if you wish to think on your own, but I'm just going to blow through this and give you my exact thought process. So we instantly identified that our boat, we need / truck thing to go through the lines is this volume thing. So here's our cube thingy. Let's assign our variables. We have a length, we have a width, and we have a height. So going back to the problem, I am going to make a quick skip. The height has to be 3 times the width. So quickly just gonna replace this with 3w. So this is a shortcut if you would like it. So from this point, I will set up my two equations. Surface area seems to be, for this section, 6w squared for this section and this section, plus 2lw, and for the front and back, plus 3wl, so 6wl. So from this point of our surface area, I am going to look for if anything's cut out, and we see that the top is open, and we see that one of the fronts, specifically one of the width ends is open here. So we will need to reduce one of the tops, which is LW. So now this is just LW. And then we need to half one of the sides, which is 3w squared and w here. So this is now just 3w squared. So that is surface area. We have completed it for this portion of the problem. Now on to volume. So volume is seen to equal 3w squared L, 3w squared L. Okay, we are not optimizing volume though in this problem. We have to be very careful. We are actually optimizing force, which is seen to be surface area plus surface area times 3,000 plus 4,000. That 4,000 is probably the giraffes. And then all of this times 39,000 over this previous term. So from this point, all we need to do is solve for surface area. So for once, it turns out we're not solving for surface area in a volume formula, which is very interesting. So going back to the problem, we find that the volume must be at least 60 cubic feet in order to fit the giraffes. So this volume equals 60. It is very interesting not to be optimizing volume in a volume identified problem. So just a whole different mindset to think about. So L seems easier to solve for in our case. Whatever makes you happy, I'm going to get 20 over w squared equals L. So put this in a nice color. This produces 20 over w squared, because the 60 over 3 makes 20 equals L. And we can plug this back into our surface area. Let's go here. So it's all in w's. So w squared, 3w squared, plus LW. So 20 over w squared times w, plus 6WL, so plus 6WL, so times 20 over w squared. So, woohoo, that's our surface area. So this is where it gets extremely nasty. So basically, this whole portion right here gets plugged into here, and this whole portion right here, I need a different color, lighter shade blue. This whole portion here gets plugged into here. So let's input this into Desmos. So we will be subbing W for X and finding where Y is the highest. So going into Desmos, we are going to type in f of x to make our life easier, equals 3x squared plus 20 over x plus 120 over x. We have to be very cautious in not being wrong, so quickly going through this, is there anything we've done wrong? Does not look like it. So this is f of x, so 3,000 times f of x plus 4,000, because that's our force, times the acceleration, which is seen to be 39,000 over that portion. So 39,000 over 3,000 f of x plus 4,000. Now we must be careful because this is going to simplify. If you look back in the problem, this is also raised to the 1.5. You can check the problem if you don't believe me. And if you get rid of f of x, we're going to check for the local maximum. And there you go. Problem solved.